Okay folks, so it's Dr. Freely's turn to record a pre-lab video. So this is the pre-lab video for Lab 5, Solubility of a Salt. Solubility is yet another physical property of compounds. Okay, so what we're going to do is take various different ionic compounds. Okay, one of which is ammonium chloride, one of which is potassium bromide, and the third one is potassium chloride. And each one of you will be assigned one of the three ionic compounds, and you'll receive an index card that has the name of the ionic compound, in this case potassium chloride, and a mass. Okay, you'll find this card at your place when you come in the lab. There will be someone else at the same lab bench who receives another card, okay? In this case, potassium chloride again, and a different mass than what you have got, okay? You're going to be sharing data. So person A will collect data using this amount of potassium chloride. Person B will collect data for this amount of potassium chloride, okay? So let me just go through the procedure, and then I'll tell you how you will analyze the data, okay? So you'll take your small vial, and you'll find these vials at your place, okay? And in this case, you're going to weigh out 2.10, or as close as you can get to it, 2.10 grams of potassium chloride. You're going to use a pre-tared weigh boat and measure out that amount, whatever amount is written on your index card. Okay? You're going to pour this into your largest test tube, not the little guys, this one. Okay? You're going to pour this into the test tube, and then using the 10 ml pipettes you've used previously and your pipette bowl, you're going to pipette out 5 milliliters of deionized water that you've obtained from the white jugs. So you're going to use your best pipetting technique and pipette out 5 milliliters. Okay? You're going to place the test tube in a water bath sitting on a hot plate. This water does not have to be deionized water. It can be tap water. It doesn't matter. Any water that comes in contact with your experiment needs to be deionized from the jugs. Okay? So you're going to boil this water, okay? And you're going to use a thermometer. You can gently stir the solid, okay, as it sits in the boiling water. And we all know that most, in your experience on this earth, most things like salt and sugar have a higher solubility at higher temperatures, as do all of these three chemicals, okay? So you're going to stir this until you see that there is no more of your potassium chloride or potassium bromide or ammonium chloride left in solution. It is all dissolved. You're then going to raise the test tube out of the boiling water bath, okay? And you're going to continue to stir it until you see the first signs of a precipitate, okay? You'll see solid, potassium chloride in this case, precipitating from the dissolved state. You'll see little faint particles, okay? You're going to record the temperature, okay, using what, 3 significant figures, okay? And that will be the precipitation temperature. Why do we do it this way? It's really difficult to see when all of a solid has dissolved. It's much easier to see the appearance of solid after it has been dissolved, okay? So you're going to do one, maybe two, a second repetition of this, depending upon the time. And Dr. Shane and I will tell you next week whether we'd like you to repeat this or not. Okay? So let's just assume you do this once. You're then going to take and add 1 additional milliliter, up to 6 milliliters, 1 plus 5. Okay? And you're going to repeat this. So you're going to heat this and stir till all of the solid goes into solution. And again, just like before, once you see that there's no solid remaining, you're going to take the test tube out so it cools, stir until you see the appearance of solid. And that will be the temperature at which the potassium chloride becomes insoluble. Okay? So, what do we do with this data? You have 2 data points. Okay? The person that you're sharing data with is going to have an additional 2 data points. This time 5 and 6 milliliters, but containing a different mass than you started with. So the combination of your data will give you 4 data points that you'll use. Okay, so this is what we're going to do. So let's take this amount of potassium chloride, 2.10 grams per 5.00 milliliters. We need to convert this to a standard concentration. So what we want to do is convert this amount of potassium chloride to the amount in 100 milliliters. Okay? So you can set up a simple equality. 2.1 grams in 5 milliliters is the same as, and I did this already, is the same as 42.0 grams in 100 milliliters. Okay? If you remember back to the density experiment where we looked at the density of different percent solutions of sodium chloride, this is a percent solution. However many grams of your solute that's present in 100 milliliters. Okay? Your colleague with whom you're sharing data will have a similar 2.45 grams per 5 milliliters, and they'll calculate however many grams are in 100. Okay? Now, you also have a data, each of you will have a data point, in this case, where you have 2.10 grams in 6 milliliters. Okay? After you've added 1 more milliliter to your test tube. Okay? If you do the math for this equality, this comes out to be, and I've already done the math, 33.3 grams per 100 milliliters. Okay? So this is a 33.3% solution. Okay? And so let's see. Let's just assume that the temperature at which this concentration starts to precipitate, the solubility temperature, is, say, 65 degrees centigrade. And let's just say this more dilute solution comes out of solution or goes into solution at 45 degrees. And then for your partner, they'll calculate similar concentrations and they'll have the data for the temperature, solubility temperature. Okay? So, what we're going to do is plot your 4 data points after you've exchanged your data. Alright, so I'm going to keep these 2 data points and plot 2 data points. So you're going to draw a graph and there is graph paper on the back of your lab handout. Make sure that your graph is large enough that you can interpret it, okay? And by large enough, I mean at least 1/3 of the page, maybe even a half, okay? Because if you make a graph that's this big, you won't be able to see anything. Okay, so on the y-axis, you're going to plot solubility. Okay, and that is in grams per 100 milliliters. Okay, on the bottom, you're going to plot precipitation temperature, and that's going to be degrees centigrade. Okay? So, what you will see is that, let's plot 33.3 and 42 grams per milliliter, 100 milliliters, okay? And so this would be 45 here and 65 here. So we go, let's do it this way, 10, 20, 30, 40, 5, 50, 60, 70, and 75. So that's going to be here, okay? And you'll have 2 additional data points from your partner. Now, what you need to do is draw a best fit line. And it should be linear. Now, my data points are all over the place. Yours will be closer, okay? Draw a best fit line that comes as close to all the data points as possible, okay? Now, there might not be an intercept at 0, 0 at the origin, and that's okay. As you approach 0, there will still be some finite solubility, okay? So it does not have to go through the origin, okay? So it's important that you plot solubility on the y-axis and the temperature on the x-axis. And there are a couple of discussion questions, and I believe that's about all you need to know. Dr. Shane and I, as always, are willing to answer questions. We'll probably give you a really short pre-lab that goes back over this, just in case you do have questions. Okay? All right. I'll see my section next Thursday.